Okay, so yeah, these are the same exact problems we just looked at. So we just got done going through here and looking at operations, arithmetic operations on functions, and but we need to add something to this because what I did is I jumped into the more complicated version of it first. I said, okay, if I want to take f of x and g of x, I want to add them together algebraically, meaning with variables. What would I do? And but we also need to look at a portion of your work is going to be just something that asks a simple question of, how do you evaluate these two functions if, and we don't need domain on this one, how do we evaluate these two functions if someone came along to us and said, oh, well, how about, what if you had, oops, what if you had f plus g of 3? Sorry, my head and my fingers are not cooperating. So what if someone just said I wanted to do this? Well, we know by definition that that means that we have f of 3 plus g of 3. Wow, do you see that? It's like the two things just aren't communicating. I need to drink more coffee. All right, so we know that's what that means. Like we know that, first of all, by definition, if we come back here and we come to this page and we steal this, make our lives a little bit easier, just take a little picture of this, right? And we bring it across with us to our other slide and we just, cheat and put that right there like that. We know that if you have f plus g of x, that means you're going to have f of x plus g of x. Well, we also know with function notation that, the 3 means that we're going to plug that in eventually. But so here we are. We got f of 3 plus g of 3. And so we can evaluate each one of those independently. So I'm going to just change colors and make it stand out. So we're going to do f of 3. So that would be 3 squared minus 10. And then we're going to do g of 3. So we'll put the plus sign in there. And let's make that a little bit neater. And we're going to do g of 3. So that would be 2 minus 3. We're literally just plugging the 3 in for the x. We simplify the first one. 3 squared is 10. I'm sorry, 3 squared is 9. Take away 10 is going to be negative 1. 2 minus 3 is negative 1. We add those together, and we find out that our answer is negative 2. So we know that f plus g of 3 is equal to negative 2. If we plug negative or 3 into those functions, we get negative 2. And so this process continues on. We can choose any combination of these. So let's do a multiplication one as an example. So let's see. We'll do f times g of x. So we know by definition, sorry, we're not going to do x. We're going to put a number in there. So let's see, let's put in negative 2. All right, so we plug in negative 2, so that means we're going to have f of negative 2 times g of negative 2. And we go and we simplify those. So we use colors again to make them stand out. And in this case here, I'm probably going to use parentheses, and I could have used parentheses here. But in this case, I'm really going to use parentheses because obviously the operation in between is going to be multiplication. Whereas in the first one, the operation was addition, so there's no need for the parentheses. In multiplication, there's a need for the parentheses. So we plug that negative 2 in, and we're going to get negative 2 quantity squared minus 10. Notice I'm being really careful about that negative 2 being in parentheses, times 2 minus negative 2. We simplify each one independently. 2 minus negative 2 is 4. Leave those parentheses around it for right now. Negative 2 squared is 4. 4 minus 10 is negative 6. So now we have a negative 6 times a positive 4. That's equal to negative 24. Okay, so performing function operations when we have a numerical value to substitute in, we don't need to, and I could have, this is just my instructional strategy. I could have done this slide first and then gone to this concept here, but I just feel like I feel like if we kind of tackle the harder piece first, then there's some things. This one's so direct. You just plug the number in, you get the answer. In this case here, it's not direct. Yeah, you plug it in, but then you have to ask yourself, well, what do you do? And sometimes you have to do FOIL, sometimes you have to distribute a negative sign. So I thought going with more complicated and then going to the easier would be a little bit easier approach. All right, last one, wrap up this video. Obviously the division one, be careful with that. You got to plug things in and simplify, but let's just not forget that when we have subtraction, the whole negative sign thing. So if we did f minus g of, let's see, negative 4. Remember that would be f of negative 4 minus g of negative 4. And so we plug those in. So we use our colors again. So that would be negative 4 squared minus 10 minus 2 minus negative 4. So in this case here, when we simplify this, we go and use what's inside the parentheses. 4 squared, 16. 16 minus 10 is 6. We can leave the parentheses on there for a second, just see if we need them. Minus 2 minus a negative 4, check it with your calculator, that's positive 6. We can leave the parentheses if we want to, but in this case here, we don't need the parentheses. The parentheses don't matter to us, so 6 minus 6 is equal to 0. So f minus g of negative 4 is equal to 0. All right, so function operations when you actually have something to substitute in, a numerical value.